Hi everyone, welcome to Computer Science E76. I'm Dan Armendariz and this is Lecture 6, the last and final Android lecture. And today we're going to get to some really juicy stuff. So up until this point we've really had to talk about quite a bit of things just to sort of get started. But now we will be able to introduce some things that will allow you to greatly expand, at least I think, the amount of applications that you will be able to create. In particular, you've seen how we can store some very simple data, and we're going to go over some of that code because we had to quickly gloss over it at the end of last week. But now another thing that you'll be able to do is be able to store more complex data as well. And finally, we will conclude at the end of today with using some threads, or having a discussion on the threading model that is used in Android. And it's probably, I've seen on the discussion board especially, that it's led to some confusion, the idea of all of these threads and processes and what's going on in Android. And hopefully you will find that it is relatively simple. Now, I do just want to mention a couple of quick things. So of course, NPuzzle is due this coming Thursday, and so hopefully you are quickly wrapping that up, if not already. But if not, and you're finding yourself with some problems, then realize that we of course have some office hours today and tomorrow that will be held on campus. And of course, the help board is always available for us to answer your questions. And we've been working furiously to try to answer everybody's questions within a timely manner. And I do just want to mention one thing about the help board as well. If you just to follow along with the academic honesty policy, make sure that if you are pasting into a discussion more than a couple of lines worth of code, then you should in fact mark that discussion as private so that other people do not look at your code. And it's I've seen that a couple of times where we've had to mark a discussion as private for that reason. So just be sure that you are doing that. Now, of course, one of the things that was released today was in fact the last Android project, the Student's Choice spec. And so you can find that and download it off the course website. Frankly, the spec, there's not a whole lot to it. At least there's not quite as much as there was in the NPuzzle specification. That's because you had to basically write your own specification. We do require a couple of technical details, like the API level version number that you should use, which incidentally should be the earliest possible version that you will be able to use. By default, your application should use the API level 3, the same version that we've been using for all of the projects and all of the source code in this class up until this point. But only if you find that you need to use an API level that's higher should you mark in your code using some comments that this specific API requires that you use a higher number, and you are allowed to bump up that API if necessary for your specific project. So we're not going to require that you dump features to be able to have this backwards compatibility. The goal here is just that you use the earliest possible version of the Android API. If we see that you're targeting against the latest version and there's no real good reason for it, then that will certainly be that will be against the specification that's here. And you are allowed quite a bit of leeway, but do just make sure that you read through the specification in its entirety, because not only do we require the source code for your project so that we can actually look at it, comment on it, make sure that it works like it should, and provide any additional feedback in that way, we also require that you provide to us a precompiled APK for your application so that it's something that we could just install on an Android emulator or device and have it run according to whatever your minimum requirements are for that specific application. And also, we ask that you just create some documentation, basically a README file that tells us what the application is all about, how we use it, what sort of things are required in order for us to be able to use your application. If you have any supplemental files, you'll need to include those as well, just so that everything for your project is sort of packaged into one zip file that you will then send to us. And so there's additional details found on the spec here. And so I realize that many of you are probably still focused on NPuzzle. Don't worry about this next one quite yet. Get NPuzzle done first, and then you can focus on the Android Student Choice. So you do have 2 weeks to work on the Student's Choice one, just like you've had for all of the other projects as well. And I do want to mention, of course, that this Student's Choice project and the iOS Student's Choice, we will actually have an app party at the end of the semester, Friday, May 13th, I believe is the date. And that day we will just have an app party where everybody is invited, everybody in the class, even distant students. We invite you to come from afar if possible, and that's one of the reasons why we made it on Friday, just to sort of make it easier for everybody to be able to attend. And of course, you can invite friends and family as well, and it will be a great way to demo your own apps in all of these platforms that you have created the Student's Choice apps for. And so we look forward to seeing everybody there with all of your amazing projects. And I don't mean that facetiously, I mean that literally. So when we're talking about data storage in Android, we've talked about how there's a variety of ways that we can store some data. And one of the things that we've seen already is using this preferences, which is very simple object which accepts key value pairs, and it's the key value pairs, the value itself has to be a primitive object, or at least a very simple object. It cannot be a complex object. And so we've seen some examples of this last week, and we'll go over it in a little bit more detail again this week. But just realize that this is probably one of the easiest ways of saving settings, for example, for your particular application, so that those settings persist from one instance of your application running to the next. Now, another that you might use is files. So whereas the preferences are not very complex in terms of what you can store within the preferences, you might want to be able to store files themselves. Like let's say you create an application, a drawing application, where you are actually creating a bitmap or a JPEG or a PNG that you want to save and persist on the device memory, then you might actually use something like files to be able to persist that data. And one of the other ways is if you have some complex data and a whole lot of it, one of the things you might use is a database software like SQLite, and we'll actually be going over this as well today. And so just as a reminder, if you have static files like images, MP3s, all of that sort of stuff belong in the resource folder. If these files you do not expect to change, and in fact they're just referenced by your application because they're going to be used in the context of your application, not really rewritten or overwritten in some way, then the resource folder is in fact the place that you want all of this data to go. Now, I do want to mention one more thing also about databases before we dive into each of these things, and that is that the database itself is actually private to your application. And in fact, this causes us a little bit of a problem when we are trying to work with SQLite databases on an actual hardware device. This is one of the ways that an emulator makes it a little bit easier to do some development versus an actual device. And you'll see what I mean when we get to SQLite databases in just a few moments. So last week, one of the things that we ended with was using some relatively simple code to persist some relatively simple data. And so the very first example that we provided basically just remembered the selection that a user had made within a menu, so that the next time the application was run, we automatically use that selection. So you might recall the Intense05 application from a couple of weeks ago, and what we did in that app was very simply just had something that looks like this, which is basically an image and a button, and it played a sound, if you recall, whenever we pushed that button. And so we used that the media player object to be able to load the WAV file and actually play it back. But one of the things that was going to be interesting, especially in this app, was being able to change the car that's actually displayed. So in Intense05, we actually had the ability to swap cars, but we didn't have the ability to show the new, or the car that the person had selected in a permanent basis. So now that the user has selected a new car, we actually want to persist that exact same data, and that's in fact what we see. Whereas if we had we not used any of these shared preferences, what would happen when we quit the application completely and reopen it is we actually find that this data does not persist any longer. And in fact, we would revert back to our original thing. And so this was done very easily with the preferences object in Android. And so we can do that basically with this method right here. We can basically just use get preferences to be able to retrieve preferences that have been saved. And so notice that we have something that's kind of interesting here. We're creating a preferences object of type shared preferences, and we use the get preferences method. Now, one of the major ways that this is actually different from storage02 is this exact method right here. This method, get preferences, allows you to retrieve preferences that have been set for this activity alone. There's a way of setting preferences so that all activities within your application can actually read it, but this, using get preferences, restricts those preferences to only this particular activity. Since this application only has one activity, this seems perfectly fine. We don't have to actually share preferences across multiple activities, so it's sort of needless to use that particular object. Now notice that we are passing in this constant called mode private that just specifies to Android that these preferences should be private to the application. This doesn't necessarily mean that if you made it mode public that it would then be allowed to share between multiple activities. Just notice that this is outside of the context of the application. So once we've retrieved our preferences object, then all we need to do to retrieve the data contained within it is to use the get type, basically, the get type method. So in this case, one of the methods that's been implemented is getInt, and this method is just a method that provides to us the integer that was stored within the preferences at this key, default car. So recall that when we save this data, we're saving it in key value pairs. So what that means is that I'm passing in a key so that will be able to fetch that same data at a later point. So in this case, when I am saving the data, I'm telling that I want to put int this the value selection using the key default car. So notice that the key in this case is a string, and you will be able to use strings. And in fact, this is perhaps one of those things where this might be a great thing to use a constant, or rather a final string, at the top of your function, or at the top of your activity rather, so that you can then generalize the use of each of these preferences, savings, and retrievals. Just because what happens is that if you happen to update one of the keys in one of the places and you forget to update it elsewhere, that could be some problematic for you in the future. So notice right here what we are doing is, so basically we'll go over this code in a second, but we're saving this integer into this key called default car, and we are then retrieving this data from this same key. But notice that there is a second parameter in this same getInt method, this r.id.hair. This is the default value that will be associated if there is no value associated with this key. So in the case that, say, this is the first time this application has been opened and no preferences had been set, we're usually going to want to have some default value. This second parameter here allows us to specify that default value. So within this application, there is a method called setCar that we call every time we want to reset the image and the sound that is being used by this application. So if we scroll down here, notice that all we are doing is accepting an integer, car, and using that int to determine which one has been selected and setting the player and the image as appropriate in each of these cases. So now, when we want to save this data, generally this means that we have performed some action that is worth saving. So in this case, perhaps the user has actually made a selection and we actually want to save that data. Now, we talked about the appropriate time to do this, and generally the best time to save the data in your application is the onPause method. And recall from the activity lifecycle that this is useful because as soon as the activity goes to the background and is paused, it is possible, though perhaps not likely, depending on the circumstances of your application and the other applications in front of it, it's possible, though perhaps not likely, that that task, that activity will actually be killed and actually not follow the remainder of its life cycle. And so for this reason, it's best to save all of the preferences, save everything that you need to save for the user in the onPause method of your activity's lifecycle. Just to make sure, just to make absolutely sure that their settings have actually been saved. But at the same time, onPause is going to be called before whatever is coming in front of this activity is going to be allowed to come in front. So in other words, if you're calling another activity or if another application is coming on top, this onPause method is going to be called and actually block that activity from being opened until onPause is finished. So the takeaway from this is that this should be very lightweight, your onPause method. You should not be doing heavy computation. You should not be doing anything that's storing gigs of data onto the SD card and onPause, just because that's going to block all further interaction from the user until it is all completed. So make onPause lightweight, and luckily using preferences is relatively lightweight, and we can store some data without too much of a hassle and without too much of a delay to the end of this particular method. So notice here that in our onPause method, what we want to do is create again a shared preferences object that we're calling prefs, but in this case we also need to instantiate an editor. So notice that there's a shared preferences.editor object that we are storing into a variable called editor, and we are retrieving from this prefs.edit method, and from that editor can we then store whatever data we want. And you don't have to store just one key value pair, as is shown here, you can, of course, store multiple key value pairs in different data types as well. And so just realize that even though you might have different types, in this case we're just using integers, you can also put other primitive data types into this editor as well. Now realize that just doing this, just using the putInt method, isn't actually going to save any of the changes quite yet. In fact, this does allow you to roll back changes if you want, without running anything else. If you don't do anything else, the changes will in fact not be saved. In order for you to save the preferences, you have to run the editor.commit method. And this is the same thing that happens if you want to flush the preferences as well. There's a method that allows you to empty the preferences, and those preferences won't actually be emptied until you actually commit it. So just make sure that every time you perform an action that you want to persist in the preferences, you will want to commit those changes in order for those preferences to be saved from one instance to the next. Now this is all well and good. Oh, I see a question in the back.
This functionality seems to overlap with standard Java util.refs functionality, and it seems that Android API does have Java util.refs. So my question is whether that one works, and why there are two of them, two different languages that provide the same.
The question is whether Java's preferences works and why there are two separate libraries. I don't know to both of those questions, frankly. I presume that there's something Android specific that perhaps makes it either a little bit more efficient or a little bit better tuned to the objects that we are using in Android, say activities and their various life cycles and processes, but I don't actually have a good answer for you offhand. Okay, so any other questions before we move on? Yes?
Can you say something about the activity stack and what causes activities to be put on the stack or go away from the stack?
What causes activities to be put on the stack and taken away from the stack? So do you mean, when you say stack, do you mean like the task, basically the list of activities or the queue of activities that the user is interacting with at the moment in time?
Well, say activity 1 starts activity 2, and then
Yes.
starts activity 3.
Mm-hmm.
Then activity 3 calls finish. My understanding is activity 2 should reappear.
Yes.
What if activity 3 issues an intent to start activity 2? Are there then two activity 2s on the stack?
Okay, so if you have a stack of activities, let's say you have activity 1 and then activity 1 starts activity 2 and then activity 2 starts activity 3, so like you said.
We could hypothetically call it image selection gameplay and you win.
Right, so I understand that this is related to the end puzzle project. So what happens if in activity 3, instead of calling finish, you instead call activity 2? So I suspect that it would actually bring up a new activity on top of it. It wouldn't actually close. It wouldn't be smart enough to realize that it can close the current activity and go back to the previous activity. And so this might actually use up more memory than is perhaps necessary, just because you were then recreating all of the objects that were recreated in activity 2 and perhaps causing one of the activities at the very bottom of the stack to be destroyed in some way by Android. And so while you might be able to do this, it might also mean a little bit of confusion to the user, because there's actually an animation that is caused when switching from one activity to the next that the user just sort of becomes slightly aware of, so that whenever a new activity is created, then that new activity slides in from the right, I believe, and when that activity is finished, then it sort of slides away to the left, showing the previous activity that was found underneath it. And so I think you might want to avoid doing this, just because you would then be causing potential UI confusion for the user and also creating some of the objects perhaps needlessly. Mm-hmm.
Let's say that you have some activities in an app that are running, and the user starts making phone calls or something, and Android destroys all of them. Mm-hmm. It still remembers the stack. Is that right?
If Android, okay, so if some low memory situation has occurred, so let's say that a user has started ignoring your application and it starts making phone calls, browsing the web or what have you, it's up to Android how many of those activities will be destroyed. So if what might happen is that it will try to preserve the latest activity at the top of the stack for as long as possible, depending on how recently that application has been used according to the other applications. But in situations where Android needs it, then it will, in fact, we'll talk more about this when we start talking about processes and threads. But what will happen is that Android actually prioritizes all of the open and running applications, and that as soon as you send your application to the background, say because you've received a phone call or because you start doing something else, then the priority of that particular application changes. And what can happen is that if it's a very low priority, that application can in fact be killed, in which case it will start over from the very first activity, the very first onCreate method, and you'll have to be responsible for recreating whatever state that application was in when it was killed. Yes?
Very simple question. With the put int or other primitives there, is it possible to put an array of ints?
Is it possible to put an array of ints into this method? No, it's not. It's a very primitive, it accepts only very primitive data types. If you wanted to put an array of some kind, you would have to perhaps serialize that array in some way, perhaps into a string or into multiple integer keys that you would then assign for each of the indices, depending on the size of the array and a variety of other things. And again, for small arrays, this is probably fine, but for big ones, then you probably need to use some other form of data storage. In the case of NPuzzle, which I'm sure many of these questions are sort of coming from, then it is possible you might actually want to use something like serialize. You might actually want to serialize the array or just put all of the various array indices into various keys in the editor, just because there's not a whole lot of those indices hopefully in your implementation of the NPuzzle. Okay, so this is relatively compelling, but where it starts to get more compelling is when we're actually able to share preferences between multiple activities. And it's not much of a leap to be able to go from a single activity shared preferences or single activity preferences to multiple activities. And in fact, really the only thing that changes is the method that you use. And so notice now in storage 02, what we are doing when we are retrieving the preferences is we are using this different method called getSharedPreferences. And getSharedPreferences actually provides to you a preference object that can be found with a given. So again, this is something that is stored with perhaps a name. So you can think of this shared preferences object as being a more generic form of the getPreferences method. And so what happens in getPreferences is that it probably uses some form, or I'm guessing it could use some form of this getSharedPreferences and just supply to it some specific name. So the way the getSharedPreferences works is that you give to it an additional parameter. In this case, we've created a new final variable called prefsName, whose contents you can see if we scroll up here. In this case, you can see that we've called it code2prefs. Whoops. And so this actually, once we share this string between multiple activities, we can retrieve the same set of preferences from this name. And so another way to think of this is that this string basically represents a preference file that just has this particular name that you are then saving to and retrieving from in any number of activities. So in this case, notice that we are getting the shared preferences from this so-called preferences file, which I'm just calling it that. It's not necessarily the case in the actual hierarchy of the actual directory structure within the Android OS. But in this case, we can just fetch the preferences that are contained within this so-called preference file and retrieve either that data or save it as appropriate. So this application actually works a little bit differently because in this case, this is a little bit more complex version of what we had actually, of the shared preferences that we had seen before. So notice that here we have a relatively simple application that has a text view and a button. And the text says, hello world code 2, and there's a button that says settings. If I hit the settings button, this loads a second activity. And in this second activity, can we actually change some of the settings that apply to the text in the first? So in this case, I can actually change the text that was visible there. So I can change hello world to hello world CS76 like that. All right. And then another thing I can do is, let's see. I can also make it bolded. And you can notice that there's a couple of buttons down here, save and cancel. And so cancel does exactly what you would expect. It would actually get rid of these changes in settings and go back to the original activity. But save, on the other hand, will actually write all of these settings now to the shared preferences object, and we will actually then see the first activity will then be updated according to whatever content has been stored in the preference file. So this is actually accomplished, and it's not really all of that complicated to be able to do this. If we take a look at this second activity, the settings activity, notice that what we're doing is relatively simple. At first, we're just fetching we're connecting to all of the UIs, and then we are retrieving all of the preferences that have been saved so far, just so that we can show the user the current preferences that they have perhaps selected. So in this case, we are getting via the get type again, whether or not the text is bolded. In this case, we're also getting the string that has been available. So notice that we're using some of the other primitive data types whose preferences we're fetching in this case. Notice that we're also providing some default values as well. And those were the default values that you just saw just a second ago when we actually first loaded up the application. Yes? So, okay, so that's a good question. So in this prefs name, if some other application just happens to use the exact same prefs name, will that actually conflict? And no, it will not. These preferences are local to the application. And in fact, we can, by specifying that it's mode private, we are saying that these preferences are private only to this application. Other applications cannot, in fact, read the preferences that are available here. So, okay, so moving on, we can see that every time we save the preferences, we're basically doing what we had done before, but instead of using the get preferences method, again, we're using get shared preferences. Again, it's a very relatively simple change, or very trivial change, really, from the previous storage 01 to this version. And then we're saving each of these values into the editor and committing them. Then when this is done, because we've actually saved the preferences, what we will want to do is finish. So notice that if the save button has been selected, then we will save the preferences. And in either case, whether or not cancel has been clicked, we will finish this current activity and return to the first. And so in the first then, how we are able to be notified of changes in the preferences, recall again the activity life cycle. So because the first activity had gone into the background, it had been paused, and now that it's coming back to the foreground, we can actually see if the preferences have been changed by looking in on resume. So this activity will now be resumed, and we can actually, even though the second activity has been closed, this first one will be resumed, and it is in here that we would then use, it would then be appropriate perhaps to look up the preferences data for this particular activity. This is as opposed to on create. If we had put all of this data here, or in on create rather than in on assume, then what would happen is that all of the data would appear when the activity is first created, but as soon as that second settings activity has closed and we come back to this original one, nothing will be updated because it has already been created, it just happens to be paused. So again, this is a matter of the life cycle where because we have gone into the background, it's simply paused and not actually completely destroyed. There was really no reason for Android in this case. Even though it could be destroyed, there's no reason for that application or that activity to be destroyed. Any questions on this? Okay. Now, if you want to read and write files, then you can actually use a couple of different methods. There's no source code examples, but there's a variety of examples found online, of course, in the developer site of Android.com. But if you want to read and write arbitrary files, then most likely some of the methods that you should look into are context.open file input and open file output. For writing files, you would use the latter. And so this, again, is for dynamic files that you actually want to modify within your application. You would then use the assets folder or some other local or shared storage, say the SD card. But if you want to use static files, you won't have to use either of these. Use one of the resource directories instead. Now, if we want to be able to switch gears and start using SQLite, realize that there's some interesting things about SQLite that really make it a bit different as opposed to a variety of other SQL-based languages like MySQL or Microsoft SQL or any of these other SQL-based query languages that allow you to create very complicated, very large databases. And in fact, you might recall that one of the binaries that are made available to us when we download the Android SDK is in fact a SQLite 3 binary. And the SQLite3 binary also happens to exist within the context of a phone with either a hardware or emulated device as well. Both of these things will actually contain within them a SQLite3 binary. So if you want to be able to modify, say, a SQLite3 database that exists within your phone, or more specifically within your emulator, then you can connect to it using ADB. And in fact, you can open up a shell using ADB's shell option and then execute this statement right here, SQLite3 /data/data, then your package name /databases/DB, or the DB name. And we'll make more concrete what each of these things mean. But basically, there is a file that is written by SQLite3 that exists within this hierarchy in the actual device memory that allows you to connect to it and actually perform SQL queries. Now realize that this works only for the emulator. If you are using a hardware device, if you've been developing on a hardware device, you're actually going to probably have to switch to using the emulator for a little while unless you jump through some hoops. The reason for that is that the /data directory on an actual device has sufficiently tight permissions that you, a developer, will not be able to read its contents. That means all of the subfolders within it you will also not be able to read. And this actually causes perhaps a little bit of a hiccup if you want to work with SQLite3 and use hardware development as well. And so what is then SQLite? Well, realize that SQLite is very much like some of these other relational databases like I had mentioned before, MySQL or MS SQL. But the major difference between each of these is that it's just very lightweight. It's a very small package. It's only a couple of hundred of kilobytes. And rather than it requiring a separate server altogether and have this sort of client-server relationship, it's actually a binary that can be linked within your application. And there's a whole bunch of connectors that exist for a whole bunch of programming languages. You can even use it in PHP if you want to use some SQLite on a database, for example. But SQLite is actually a great way of having some simple relational database technology available to you within a mobile device. And in fact, not only does Android use it, but I believe iPhone uses SQLite3 databases as well. And so this is sort of an interesting way of being able to record data. Now, one of the things that's nice about SQLite is that if you have used Excel, then you've basically used something like SQLite. So if you're not familiar at all with relational database, it's basically just like this. It's basically just gives you a whole bunch of rows and columns, and you define ahead of time the rows that exist, or rather the columns that exist, and each of these are called fields. And within each of these fields, can you add rows of data? So you might, for example, if you're implementing a contact list, just as an example, you might have some fields that include first name, last name, telephone number, address. And then you would have rows for each person within your contact list. You can think of a whole variety of ways that you might actually want to use this, and storing all of this data is perfect into something like SQLite. Now, for those of you that are familiar with other SQL query languages, you'll feel relatively comfortable here as well. There's a variety of statements. In order to work with the data in SQLite, just like you would work with data in MySQL or MS SQL, you actually have to issue statements to this language, to SQLite. And what will happen is that you create these statements in very known ways. And so usually you have something that has to, some verb basically that has to happen like one of these. So each of these statements applies to different contexts worth of data. So whereas I had mentioned before, we have rows of data, that's where we can have an individual row of data representing, say, one contact in a contact book or in an address book. The entire data, all of this data set within this address book might be considered one table. So that's the difference that you are seeing here. So we have some statements that apply not only to rows individually, but also to tables generally. So that you might want to, for example, create a new table. You might want to, the first time you load your address book application, for example, you actually need to create your address book table so that you have somewhere to start inserting data. So then you might use the create statement as shown up top. And then if you want to start inserting rows of data into your table, you would then use, say, the insert statement as shown here. Now, some of the most common ones you will typically use are the insert statement and the select statement, just because you are either inserting data into your pre-existing tables, or you're trying to fetch data and looking to see what sort of data you have made available to yourself already. So a typical statement then might look something like this. So if we have a table called users, and we want to change the email address of one of the users, we might do something that looks almost exactly like this. And in fact, we would have an update statement where we're updating some rows from the users table. So we're updating users, and in this case, users is a table. We are setting a field called email equal to something, and in this case, the help list, help@cs76.net, and we are specifying which row using a condition statement, this where user ID equals 4. So there's not a whole lot that we can gather from a table that this statement would work on, but we can gather a number of things. First of all, we can tell that this table is called users. And within this table, we have at least 2 fields. One field is a user ID. That's sort of a numeric type of some sort, and you can see that that is perhaps based on its name supposed to uniquely identify that row and that user within this table. But also we have a field called email. And based on the quotations, you can tell that this is sort of a string, that we're trying to store this string into this specific row. And working with data, you can actually update data in this way. And in fact, using an ID is very, very important, and in fact is sort of required even by Android. As we will see just a little while, it's important that you have an ID field so that an individual row can be looked up, selected, or updated, or inserted very, very easily. So this entire thing is a statement. Notice that's a SQL statement, and this applies to the SQL query language in general. This isn't even specific necessarily to SQLite 3, but this could work in MS SQL, it could work in MySQL, it can work in a variety of other languages that support the SQL query language. But notice that at the very end, there is a semicolon. So just like sort of a programming language that you've gotten used to, we do have to terminate our statements with this particular, with the semicolon. Now the documentation for SQLite is relatively good, but I recommend if you are interested in using this because you want to have some database capability within your application, look at the docs. The reason that I say this is that SQLite is actually quite a bit different from all of the other query languages, all of the other SQL query languages that you might be familiar with. If you came from with a background in MySQL, perhaps because you came from E75, for example, SQLite is going to look very, very familiar to you in a lot of ways, but there are going to be some things that unless you are aware, you're going to sort of rip your hair out. And one of the things is the typing that SQLite uses, whereas almost all other SQL languages, all of the other ones that I know of at least, are very strictly typed. When you define a field, you have to define what sort of data that field is. You have to specify whether it's an integer, whether it's a double, whether it's a date, whether it's a string, and many times you even have to specify the length of the string, the maximum length of the string that can exist within this field. And that's not so in SQLite. In fact, you can store any kind of data anywhere almost all the time. And there are, of course, some rules that you will have to follow, but generally, it's going to be a little bit confusing unless you follow some basic guidelines to insert data into SQLite. So these are the various storage classes, as SQLite calls them, that you can use for a particular field. And again, another word for field is a column. So you might have an integer, for example, which could be a signed integer, or a real, which would be a floating point value, text, or a blob. Now, realize that there's, there's no Boolean value. There's no way of specifying true or false. If you do specify a Boolean value for a field, what that will essentially come down to is using an integer in either a 0 or a 1. So just realize that there's a whole bunch of simplicity that has to happen if you're trying to port some complex data from a MySQL table or an MS SQL table into a table that might be used in SQLite. So if we have each of these, if we have different data types, so let's say that we have these various data types, what sort of data can we store in each? So let's say that we have a field that has been specified to store a text value, just as an example. So that field is then said to have an affinity towards the text type. But what this really means is that you can store either null or an actual string, some actual text, or a blob within that text field. Some other things that you can do, if you have numeric data type, for example, you can pretty much store anything within it. You can store strings, you can store numbers, integers, all of this stuff can actually be stored within the numeric data type. An integer is basically just a synonym for numeric. So again, this is very, very loosely typed. You just don't have to, the idea is that you have to worry less about the types of data that you're inserting into it, but coming from strictly typed query languages like MySQL, you might cause a little bit of confusion. So just pay attention to each of these type affinities. Did I see a question in the back?
I'm not sure if this, but does SQLite allow storage of images and documents like SQLite, like regular?
Does SQLite allow storage of images and other arbitrary data? So I would say, well, yes and no. Yes, in that I don't think it's technically disallowed, but that's really not the point of what this is supposed to be. You really, if you're going to be storing data or if you're going to be storing files, you might as well do that on the file system itself. And there's, so like we had mentioned before, that's the case where you would use one of those files things, and you would actually open up a directory and insert some files into that directory. You wouldn't actually store data like this. This is meant to be much lighter weight than that, and to actually store perhaps some relational data that might exist in a database. Yes?
What does the footnote mean? Integer same as above except when converting float to an integer.
So there is, so when, let's see. Yes, so there's a footnote here. So there is the numeric and integer data types are essentially identical except for the case when you are trying to convert a float. So you'll notice that there's a variety of types that exist here, and because of how loosely typed this is, we're actually going to end up converting from one type to another just to be able to do some comparisons. And there is, let's see, now that I'm put on the spot, I forget exactly what it was, but there is some different way that a field type of integer behaves differently when you provide a float to it versus the numeric type. I believe what happens is the numeric type will actually store the float itself, whereas an integer may actually cause that to be cast to an integer. But we'd have to look that up in the documentation. Yeah?
Can we establish a relationship between tables and SQLite?
Can you establish a relationship between tables and SQLite? So yes, it is a relational database. You will be able to establish relations just like you would in other query languages. In fact, SQLite does implement quite a lot of the SQL query language. There are some exceptions to that can be found in the documentation, but the vast majority of the things that you can accomplish in, say, MySQL, you would also be able to accomplish in SQLite. But there are some gotchas, like you can tell from these types, and also in the statements that are allowed as well. Yes?
What kind of limitations are there for size? For example, could you put a MP3 file into a lot of storage?
There is a limitation in the size. There is a field max. So when you define a field in SQLite, it will actually ignore a maximum field size. So for example, if you are using and if you are used to MySQL, you might recall that you can actually set the size of a blob field or the size of a char field up to a maximum size. Those maximum sizes are ignored in the case of SQLite. It will actually, so if you have something like varchar 24, for example, it will ignore the 24 in that particular case, and it will allow any size of data to be inserted up to a maximum. There is a maximum that is allowed within SQLite. I don't know what that is offhand, but it is pretty large. But again, if you're actually going to be storing some data like MP3s or something like that, that's probably more appropriate to be stored in the file directly rather than strictly right into the database, just because that's exactly what the purpose of the file hierarchy is, to store the files that you want to save for your application. Okay, so let's take a look at how we might actually work with some of these. So if I am working with SQLite, one of the things that I might actually want to do is to create a, database and start working with it. So in order for us to do that, what we have to do is find SQLite 3. So in this case, I'm just going to be working with SQLite 3 locally. And we are provided actually a SQLite 3 binary within the Android SDK. And so you wouldn't use typically SQLite 3 the one that exists in the tools directory of your Android SDK folder, to be able to access the SQLite 3 databases on your emulated device. For that, you would instead use the ADB shell, like I'll show you in just a little while. But at least if we want to, perhaps let's say we've downloaded the SQL file from our device, or we want to start creating one from scratch on our own, we can actually work with the binary here. Now the nice thing about a SQLite 3 database is that it creates a single file. And this file contains not only all of the definitions for all of the tables, but also all of the data for the tables as well. And what this means is that it is essentially portable. You can port that file from one device to the other, and as long as you have SQLite 3 on each of these devices, you will be able to open and interpret the data within that same file. And compare this to something like SQL or MySQL, for example, where it manages a strict hierarchy of files and folders. There's a form file, for example, that actually stores the definition of the table, and then there's I think it's MYD for the MySQL data itself, and then it becomes sort of a nightmare managing all of those files. This makes it relatively easy to do. So in order for us to do this, we can do SQLite 3, oops, I have to do this, SQLite 3, and then a database, so in this case, test.db. Now notice that we are provided with basically just a SQLite shell. And from here, you can start issuing those statements that I had mentioned before. Now, one of the best things to do the first time you look at this is to actually run the help statement and see what sort of things you will be able to do. If you get stuck at any point, run .help, and you will be able to see the sorts of things that you can do here. So, oh, yes, question?
When you say that the SQLite file is portable between devices, do you mean from Android device to Android device, or is this a universal SQLite format that would work on other implementations on other platforms?
So SQLite 3 is meant to be universal across platforms and devices. So I can actually create a SQLite database on my computer and upload it to, say, an Android device and be able to interpret it. Or I could move it over to a Linux server that's hosting a web server and use the SQLite as its database management, for example, and it should work there as well. So long as the versions are within reason, then that will also work. But generally, SQLite 3, which is the version that we're using and that's most common nowadays, will work in this manner. So notice that if we actually want to see the list of tables that we have in this database, I can run the period tables command. And in this case, it returns nothing because no tables have actually been created quite yet. So how do I create a table? Well, I'm going to create one that looks like this. So I'm going to use a create table syntax. And so this should look very, very familiar to all of you that work with this, with SQL queries before. In this case, I'm going to call it T, and now I'm going to define the fields that exist within it. So in this case, I'm going to call the first field T and give it a type of, or a text, an affinity of text, and then N for numeric rather. Let's see, I'll do a couple more, I for integer, and let's see, let's also do R for real. Okay, and then when I'm done, then I can close my statement. So notice that it continues. You can sort of wrap onto multiple lines. It's the semicolon that notifies that you are done typing these commands, and it will actually issue this statement. So now, if I run tables, we can see what sort of tables I have available to us. And in this case, if I want to find out what the schema is, I believe it's .schema, and then the table name, and we can see the statement that was used to create this table and the affinities, the type affinities that were used for all of this. So now, right now, I'm using all of the type affinities that I mentioned SQLite actually uses. But realize that there's actually some rules that if you were to use a create table statement that you would get from, say, MySQL, it would actually interpret that, and it would convert each of the field types into whatever affinity is appropriate, based on some set of rules that exist within the SQLite documentation. So from here, I can do a variety of things, like I can actually insert data, so insert into T, and then values, and then I can provide into it some values. So in this case, 500.0, and I'm just going to enter the same thing into all 4 of these fields so we can look to see what exactly is happening, just to give you sort of an example of what these various affinities are doing to us. So 500.0. I'm sorry? So no. So do you have to enclose in quotes even the numeric? So this is exactly what it is that I want to show you, is that what happens when I actually try to insert data like this into a database that has this sort of loosely typed affinity. So again, the documentation is pretty good. It has some pretty good examples of what we might want to, of how this will work. But if I want to find out these, let's see, if I want to find out the type of, say, the integers, so in this case type of n, what we should see is that, let's see, select type of from t. That's what we want. So we can see now the sort of data that has been inserted into this particular database. And so this is actually, again, the typing for SQLite, because it's loose, there are some complexities to it. And we're not going to have a chance to go over all of it. I just want to enable you to be able to look into each of these things yourself, but realize that we have here various types of affinities and that there are column affinities as well. So that when we are defining a field within a database, the affinity that is going to be provided is going to follow basically these rules here. So if the type contains int, for example, it will be assigned an integer affinity. There's a whole bunch of rules that it will follow in this case. And when we actually do some comparisons, it's important to realize that there are some loose typing issues. Now, generally, all of this should be, this is designed to be sort of intuitive in a sense, in that, yes, there are formally described rules, but when you actually get down to working with it, hopefully it will start to make a bit more sense. And so now that we have this concept that there is this database that we can insert data and that we can select data from, how do we actually use it in the context of an Android device? And to find that out, let's first take a quick 5-minute break, and when we come back, we'll continue talking about SQLite, and then we will talk about threading. Hello everyone, welcome back. So, how do we then use this SQLite database in an application in Android? And so realize that there is actually a class that's made available to us called the SQLite Open Helper. And by extending that class, can we then create a Java class that allows us to work with a SQLite database. Now, there is a little bit of work that we're going to have to do, and I know what some of you are thinking. Should I use SQLite to save the state in NPuzzle? The short answer is no. And the reason for that is that it is complicated. And if you're looking at Storage03, if you've downloaded the source code and you're looking at it on your in Eclipse, you'll notice that there's actually quite a bit of stuff that has to go on just for us to be able to do some relatively simple things. Frankly, it's going to be simpler for you, in my opinion, to be able to serialize a simple object into something that you can store in preferences or shared preferences. And so the reason that you would want to use SQLite is not perhaps for NPuzzle, but in fact, most likely for something like your own Student's Choice project, just because you might want to actually store vast quantities of data, or more than just what is hopefully a relatively simple array, or a relatively simple two-dimensional array of objects. And so in this case, what we want to do when we want to create a database is we have to extend the SQLite Open Helper. And this SQLite Open Helper, when we instantiate this class, it calls for us, just like there's a variety of methods that sort of are called by Android in the back end that we don't ever really see, like the dialog, for example. When we created a dialog, we didn't actually implement I believe it was called the show dialog method, but we in fact implemented the method that was called by the show dialog method. And this is the same sort of thing. What we have to do is create a constructor, create an onCreate method, an onUpgrade method, and there's also one more down here. Oh no, there's not. I think there's another one that's optional also that you can find in the documentation. But when a database or when a SQL Open Helper class is instantiated, it goes through a variety of steps. First, it's constructed, and then it checks to see if the database exists, or rather if the table that you want to work with exists within the database. And the reason that it might not exist is because it's, say, a new installation of the application and the first time it's being run on a device. And so this might mean that there's actually no data quite yet in the database. And so you have to then be able to create the table within that database. And so this onCreate method is called in the event that there is a database that does not yet exist. And so notice that what we are doing is we are running this exec SQL method using a string that's called dbCreate. And you'll notice that in some other aspects, in some scrolling up a bit in this class, we have a variety of things that we've defined that define the layout of our schema, that define the layout of our table that we're using in SQL. So in this case, we can see the dbCreate statement that we're using. In this case, we want to create a table called users with the field _ID, integer primary key, auto increment. All of these are sort of SQL specific. I'll have to do some hand waving and refer you to the documentation if you're not too sure what they mean. Then we need another field called user that's of type text, and a password that is of type text. And this is for a very, very crude example of how we might actually use SQLite. This is one of the many times that I will say again, do as I say and not as I do. Don't actually store somebody's password in a SQL database because it's not encrypted and it's possible to be read. This is just meant as an example of a way that we can easily insert some data and easily query for that data. That's all it's really meant as. It's just as an example, not something that you should perhaps use in an actual production or in an actual application. Now, when this database has been created, there's another, or if the database has already been created, there is something else that's run as well, this onUpgrade method. Now, onUpgrade is called dependent on the version that you pass to this constructor. Notice that in this constructor, one of the things that we're passing to it is a db_version variable. And what this variable has is basically just a version number associated with our database. The reason that we might have different version numbers is that if you create a newer version of your program that perhaps has a more complicated or even a simpler version of the table that you want to work with, that newer version is not going to be compatible with the old table from the older version of the application. So in the instance, so we've already covered the instance when you've downloaded the application, you're running it on your Android phone, and it's a new application. It's a new instance of this app, and so what's happening then is that the table has to be created. Now instead, what happens if we already have all of this data on the phone and we now we download an upgrade to this application that somehow changes the tables? That is what this dbUpgrade method does, is it compares versions reported by the class. So in this case, we're using a version 1, and if we have to upgrade the tables, then we would upgrade this to version 2. And in doUpgrade, what we would do is modify the table as appropriate, perhaps dropping the old one and then creating the new one. Or if you were actually doing this in production quality or in an actual release quality thing, you would actually port the data from the old table to the new table and then remove the old table perhaps. And you would implement all of that in this onUpgrade method here. Now, once you have all of this sort of administrative stuff set up, then you can actually start to work with the database itself. And realize that we're doing all of this in a single thread. And most of the time, what people tend to recommend is if you have a lot of data, if you're saving a lot of data, that you do this in this sort of concept where you store all of the data in perhaps a separate thread. And that, again, is something that increases the complexity of this a little bit, but we're sort of showing just a little bit here where we have a separate class to actually store and retrieve our data. But notice that what we are doing in the onCreate of our actual activity is instantiating the DBD adapter and creating a connection to the database, to the SQLite database from here. And so notice that when we're actually running this application, what it looks like is something like this. Let's see, it's up here. It looks something like this right here. And this is just a very basic application. It has a username and a password field with the save login button and an authenticate button. And this is yet another reason why you shouldn't actually use this code, because somebody can allow themselves to authenticate by just including themselves in the database. But the reason that I'm using this emulator is because of this problem that I had mentioned before. It's actually not possible had I run it on the phone. It's not actually very easy, at least, for me to show you the database contents from the Android phone itself. But instead here we can see the database that exists. So I can actually list the tables that exist in this in this device, and in this case you notice there's two tables, Android metadata, which we're not going to touch, and the users one, which we've actually created based on this class that we've instantiated. And I can also see the schema of this table. We can see that it is exactly what we created in that string before. Create table users, the underscore ID, which is the reason that it's underscore ID is because Android also uses it, so it's important to name it in that fashion. There's also the user field and the pass field. And if I actually look to see what data exists in this table, you'll see that there is not yet anything. So right now what I could do is actually insert some data into the user's table. So in this case, I want to have a username of Dan and a password that's super secure of 1234. Oops. Oh yeah, I have to insert an ID as well. Insert into users, values. Let's see, Dan and 1234. Now hopefully this will work. Oh no. Okay, and the downside to doing it this way is that you can't actually hit up to be able to go back to your previous command. Okay, so now I can look to see what data I have in here, and we can see that I have, and again, SQLite is very basic. It only shows you that there's some data here, and it doesn't show you a fancy table like you might be accustomed to in MySQL. In this case, you can see it has an ID of, oh, it's doing this stupid thing again. It's doing, it has an ID of 1, and it has my username and password. So now what I can do is go up here, type in my username, which is Dan, and I can type in my password, which is 1234. And what will happen is that I can then, as soon as this, I can authenticate, and we can see that it has been authenticated. So what's happening is that I'm querying the database for this data to see if this data actually exists. If I were to change the username or the password because, say, I've not authenticated correctly, I'll just type any number of things here. Then when I hit authenticate, you'll notice that the thing that appears at the bottom is that it says authentication failed for this username. So basically all we're doing is we're just using these buttons to issue some statements via SQLite to the back-end database that exists. And so you'll notice that there's also a save login. I could also insert some data, like I could actually type in, instead of this, I could type J Harvard and a password of Crimson. And what this will allow me to do as soon as I hit save login is you will then see in a second that data has been inserted into the database as well. So select star from users. Notice that now I have 2 rows of data within my database. So again, this is just sort of a proof of concept that you can use SQLite and how you can start working with SQLite within your application. Yes?
I noticed that the schema for the table says auto increment for the ID column.
Yes.
That when you try to insert without specifying the ID value, it did not allow you. So I wonder how that auto increment works. How do you say to the database and insert statement to use the auto increment value?
So right, so the value, the ID value does in fact have an auto increment value. And when I was trying to insert the data, I had to manually set the value, and that's because I didn't specify. I used the values keyword and not without specifying the columns. And so what that meant was that I had to specify the data for each of the fields that in the row that I'm inserting. And I had to then manually insert the auto increments. However, when we actually insert the data if we were to use a different statement, you can actually specify only the 2 fields that you want. So without specifying the auto increment, and it will actually auto increment up based on the next highest integer that that you can use within that field. And let's see. So the next, it's going to be the next highest integer that you can use in that field. So for example, if we were to use when we implement this in Android, we can actually cause an insert. So where's the insert? Let's see. Oh, it's right here. So when we actually want to insert this data, we pass the user string and the password string to this function that exists in the DB adapter. And what we want to do is insert some data into our table. So in this case, we have content values, which is just an object that allows us to interact with some content in an Android content resolver, which is specific to Android. And this allows us to add some key value pairs. And in this case, the key is the column or the field that we want to insert, and the value is the value for that column. And so in this case, again, we're using this concept of final keywords or final strings so that we can have this easily defined at the very top of the file. But I'm just saying that I want to insert into the user and the password fields the username and the password as supplied by the user, and insert that into the table. And so there's a couple of methods that are supplied to us that make that sort of thing easier. Now, if I actually want to perform a query, and again, to make this a little bit more real, when we actually click on one of the buttons in the activity, what's happening is that we are running one of these two methods within the from the DB adapter. So notice that we have db.insertUser, and we're just inserting the username and password that was supplied to us. Then we test to see what the ID was that was inserted. If the ID happened to be -1, then that just means that there was some error of some kind. Otherwise, we can say that that user has been successfully inserted, just like you saw just a moment ago when we actually looked at the raw data that exists within the SQLite database. And so in this case, or in the case that we actually want to authenticate the user, then there's another method called authenticateUser that you can see returns either true or false. It returns a Boolean dependent on whether or not the user has properly authenticated, and that method looks like this. And basically, we're just going to be creating a query and building it using this cursor object. So what we need to do is pass it the table to perform the query, the result set columns that we actually want. So in this case, it's very much like if we wanted to find out, so we can actually convert this to sort of a raw SQL string or to a raw statement. So it would actually look like select, let's see. So I will try to make this a little bit bigger. So what this essentially translates to is, and again, there's some comments here that sort of help you identify what is happening. And select, normally we say star to return to us all of the fields within the row that we are looking for. In this case, we're passing just one field, and that is the key user. So in this case, we want to select the user. So what is the name of key user? I think it was just user. Yep. Select user from, and then the DB table, which was called users. And then we have a condition where, and then that condition is listed here, as you can see, where key user equals question mark and key pass equals question mark. And this is sort of printf style, where those question marks are then replaced with data from the very next parameter, user and password. So in this case, then, what we are looking at is this, where user equals, and then say Dan, which is what I had entered before, and pass equals 1, 2, 3, 4. And so this is essentially then the statement that is issued but is built using this cursor. We build this statement using the cursor, but this is the statement that is then issued to the database, and the result is given back to us. And when we look at the result, we can actually find the number of rows. And if the number of rows equals 1, because there should be exactly one row that contains that user and that password at the same time, if we get one row back, that means that that user has been authenticated, and we can return true. If we have, say, no rows returned, that's because either the username or the password is incorrect, and so we would then return false and notify the user in that manner. So again, this is just sort of a crude and simple example of how you might start to implement an adapter that allows you to communicate to a SQLite database in your application. But like I had mentioned before, one of the things that you might actually want to do is thread this, because you might actually have a lot of data that you need to read and write, and especially, it doesn't even matter for, or it does matter for this, but it doesn't even matter the type. You might actually have some very computationally expensive algorithms that have to run. Now, I will say that you do not need to use threading for NPuzzle. That's overkill. And so just realize that this, again, is meant for future projects, and specifically your student's choice project, where you might actually need to implement a thread. But with all of that said, realize that by default, an Android application is single-threaded and runs in one process. And so what this means is that even you can actually have you could actually have, say, a service run in an entirely different process, but by default that's not going to be the case. It's all going to run within the same, essentially, Linux process. And when you have one activity, that is going to be run entirely within a single thread. And so what this means is that if you are doing something that causes a lot of computation on the UI thread, you can actually cause the UI to hang for a certain amount of time. And many of you might have actually noticed this. If you were trying to implement the timer in NPuzzle, for example, you might have noticed that just by using the typical Java's thread.sleep method, you actually are causing the entire activity to hang. And that is the point of Threads 01. Threads 01 is really just meant to be sort of an example of what you should not do. Because it is very easy in Android to get to a point where a user gets just sort of a bad experience. So to show you, we have here running on the device Thread 01. And so notice that there is a silly little cartoon, and if I tap it, it starts to animate. And so all of this, again, is happening on the UI thread. So right now, nothing else is going on. So it can perform this animation. But let's say that by pushing this button that's labeled sleep at the left side here, that what happens is I'm going to actually call what is the equivalent of thread.sleep. So when I do that, notice that you didn't really see the button sort of being pushed, but now the UI is locked. In fact, nothing is happening. And so, okay, so yes, I did wait 10 seconds, but as a result, because it's all single-threaded, I caused the entire thing to lock up. And this is an overly simple example. Instead of using thread.sleep, what if you were using some loop that was supposed to do a lot of computation? In this case, you might actually block the thread unintentionally as well. So notice what happens if I hit sleep, and then now I start trying to do other things and nothing is really happening. Notice what's going to appear in just a second. The dreaded application not responding message will actually appear. And the reason for that is that Android OS is monitoring what's going on. If the user is tapping and the UI is not responding to taps, if none of these events are actually being fired when this is happening, then you will get this after about 5 seconds. And this is bad. So basically, you cannot have any process running for longer than 5 seconds, and that's the upper limit. Frankly, you shouldn't have any process running in the UI thread for longer than maybe 100 or 200 milliseconds, just because that's enough time, that's a short enough time for the user to notice a delay. So if you have something that's causing this sufficient delay that's longer than about 100 or 200 milliseconds, and especially if it's at risk of running for longer than 5 seconds, then you are at risk of getting some UI problems. So you can see here that we are allowed to wait, but most likely a user that sees this message a lot is actually going to be sort of annoyed by your application. And in fact, it is very annoying, especially when you push on a button and then nothing happens and you're pushing on stuff and look, nothing is going on the screen. This is very annoying to us as users. And so many users actually might select the force close option and just forego this program altogether. Now notice that there is something else. Now one of the things that I've seen on some of the discussion boards is that, okay, well now maybe I'll use a separate thread and use this object that's called a runnable. And I'll show you what a runnable is in just a moment. But basically, and it's going to look as though what I'm doing here is very, well, it looks like it's multi-threaded, but just keep in mind that it's not. This is still single-threaded. So basically, there is a runnable. And basically, with the runnable, can I post some method that is going to be called within a certain amount of time? So this is, in essence, sort of a timer, in a sense. There are many ways of using a timer, but realize that this is just one of them. And this one, even though now I am running some timer in the background, apparently, for about 10 seconds, now the UI is not locked. So you might think, okay, this is obviously now multi-threaded, but in fact, it is not. So let's say now that, so basically all that happens is that I'm posting this runnable, and I'll show you the code for this in just a moment, and I'm telling the runnable to actually run this method that says, that will display that message that says I've waited 10 seconds, and that's all it does. But let's say now that what I do within this runnable is actually sleep. So after 10 seconds, it's actually going to cause asleep. So what's going to happen is that the runnable is going to be posted after about 10 seconds. What you'll notice is that the runnable calls this method that I had mentioned before, and what's going to happen as a result is the UI hangs. So it's the exact same thing as before, whereas now, okay, we are still causing the UI to hang. This is still single-threaded. The methods that we are calling as a result of this runnable are still happening within the same thread, and we can still cause the UI to hang. So just by nature of it being a runnable doesn't necessarily mean that it is multi-threaded. Now with that said, I will say that with runnables and handlers, this is actually the appropriate way to send messages from one thread to another, but it doesn't necessarily imply by itself. You actually have to go through the motions of creating a separate thread. So let's take a look at this code and how we can avoid this dreaded application not responding, or ANR. So notice that we have here a relatively simple onCreate handler, but what is interesting is what happens when we click on something. In this case, if we want to, so when you click on the image itself, that's what causes the animation to start in the same thread. Now if I hit sleep, then I use the system clock.sleep method, which is kind of equivalent to the thread.sleep, and you can see more information on timekeeping at the URL that's available in the comments here. There's a good discussion about thread.sleep versus system clock.sleep. But basically what happens is that I'm just causing this UI thread to hang. So now what about this runnable situation? Well, notice that I'm creating a handler. So there's a couple of different objects that are in use here. One is a handler that you can see is instantiated at the top there, h equals new handler, and that handler is responsible for posting the runnable to be run. What this means is that the handler is actually responsible for some messages. And what I am doing is I am telling the thread that in about 10 seconds, so there's a timer here of about 10 seconds, that in 10 seconds I want to call a runnable called wait for S. And so what this means is that it's going to be queued up in the message queue for that thread. And after 10 seconds, will that thread realize, okay, now I'm supposed to run this wait for S runnable, so I will go down here, find the runnable code, and actually run this code here. So notice that we have here the show message block that actually displays waited for about 10 seconds. And then there's an if statement. If that little checkbox was checked, will we actually cause that same sleep cycle that we had seen before? So this is meant to show that all of this stuff, even if you are using a runnable, this is still single-threaded. And this is not a good solution to being able to run some stuff in the background. You can't just create a runnable and use a handler to post that runnable to the message queue and then run that after a certain amount of time. That's still going to be run in the UI thread, and you could still cause your UI to block and cause the dreaded ANR to appear after about 5 seconds. So just keep that in mind. But this runnable is useful. I do want to point out that this is actually useful because if you do have something that you want to run in the future, you can just create a handler. You can use the post-delayed method to run some runnable at some future time. And it's approximate, but it's pretty close, especially if your thread isn't doing very much besides just perhaps animating or doing something relatively simple, then it will be run at the appropriate time, and then this code can actually be run at that moment. But again, this is still single-threaded. Now you could, in fact, use Java threads to accomplish this task, but you have to be very, very careful when you're starting to work with multi-threaded processes within an application. The reason for that is that all of the UI updates occur on the UI thread. And they're not thread safe, which means that you cannot call from another thread some update to your UI. You cannot call some text view to be updated. You should not handle button clicking on another thread. All of this stuff has to happen on the UI thread, or you will get into trouble very, very quickly. And you might have, well, you may not run into trouble immediately. It may not be very quick at all, but you might start seeing some weird behavior, and it might be extremely difficult to diagnose. And thread handling is sort of one of these things that can be a little tricky to diagnose when it is problematic. So Threads02 now is supposed to be a solution to this problem. This does in fact support multi-threaded, it does actually have multiple threads within it, so that we can actually then do something in the background and allow the UI thread to continuously update as well. So let's see, so what we should see in just a moment here is the threads02, you notice that there is an animation here again, and there is now a button that says asynchronous. And so when I hit this button, this will cause another thread to be run, and at the same time, will there be a thread.sleep for 10 seconds. And so to simulate me actually performing some work in the background. Oh, and by the way, this emoticon I just got from some website that's cited in the drawable folder, but I figured this was very appropriate for those of you that are frustrated with your end puzzle project. So anyway, so you'll notice that what happened after about 10 seconds, even though there was a thread.sleep, which is essentially simulating a thread working for 10 seconds, you'll notice that it does not cause the UI to block. And yet still can we run a message on the UI thread to display to the user some update that's happening. Now notice that we're not actually using the Java thread support. And in fact, you can use Java threading if you want, but there does exist within Android one class that makes this at least simple multiple threads relatively easy. And that uses an object called an async task that you can see here. So what I am going to do is then create a class that extends this asynchronous task. So this asynchronous task handles all of the threading for me in the background. I don't have to worry about actually creating another thread. I don't actually have to worry about which methods are going to be run in the appropriate, well, I do have to worry about that, but it makes it very obvious which methods are going to be run in which thread. So you'll notice that there's a couple of methods that we're able to implement. One of them is this doInBackground method. And this doInBackground method, when we actually execute this asynchronous task, it is the contents of this method that are actually run in a separate thread altogether. And so this thread, this system_clock.sleep or thread.sleep doesn't actually cause our UI thread to block because it's running in the background. Now, once that method actually completes, and again, this is another one of those examples where the Android OS is actually calling different methods for us, and it's invisible to us which ones are happening. We just happen to know by reading the documentation the order and what will happen, which event will be called after a given event. Notice that once this is done, onPostExecute will be run. And onPostExecute is the method that will be called in the UI thread once your background task has completed. And this means that in onPostExecute, can you actually access the objects that are available to you in the UI. So you can actually access the UI the toolkit, and you can actually update whatever views and whatever objects you actually want to create in your original thread without having a fear of running into any sort of concurrency issues or anything like that. So notice that this is very, very simple. All we're doing is in the background, we are saying that we want to sleep for about 10 seconds. Then when that's done, do we show the message on the UI thread that we've waited for a certain number of seconds? Yes?
What does that ...
Yes, so there is some there's some sort of complications with the typing. So notice that we're using generics here. If we want to actually pass some data to the doInBackground method, and if we want to return some data from this method, we actually have to specify each of these each of the types in this generics, and I'll show you there's a more complicated example in threads03 that actually makes use of this rather than just using void for all of these. But the ... after the type in doInBackground, this right here, and replicated again there's another method that uses this as well. It basically just means that it's accepting an array of this type. So this params is basically an array of type void. That's basically all it means in this case. So we'll look at a more complex example in just a minute. This is just meant to be a very, very simple example that's meant to show you how we can do this. So on create, there's no surprises. Show message, there's no surprises. But on click, when we actually click that async button, notice that all we're doing is instantiating our class that we've extended from async task, and we're calling the execute method on it. And that execute method is then responsible for spawning a separate thread, running the doInBackground method on that separate thread, then being notified when that thread is done, then running the onPostExecute method on the UI thread. All of this stuff is handled for us. It makes it very easy and makes it very nice to be able to run some things in the background. Now, of course, you don't get everything in life for free. There are some gotchas with using async tasks. One of the most important ones is that you cannot run multiple async tasks of this type. So do some task. In this case, we cannot run multiple of them at once. So what this means is that we can't, if we wanted to, say, download a whole bunch of images in the background, we can't create one class per image and then execute each or queue them up, because that is not going to work. You'll get an error from, you'll actually get a runtime exception. I forget exactly what it is, but it's like, I don't know, activity already being, or no, background async task already running or something like that, illegal state exception, something like that. So you can't actually do that. So there's potentially some hoops you'll have to jump through if you want to be able to process multiple bits of data at once. So how then can we actually process multiple pieces of data? Because really, what's the point of a background thread if it's going to be a single item that we want to process and it's not going to take us very long? What if we actually want to do something that takes an appreciable amount of time? So threads 03 builds upon this idea, and it also takes bits and pieces from Intense 08. Remember, Intense 08 was basically, it used the grid view and showed us, used the image adapter to show us a variety of thumbnails. Then we could click on one of the thumbnails, and actually it was basically a gallery application of some images. But now with threads 03, we want to take this same idea to the next level. And in fact, what is going to be run is this application here, which looks a little dark right there, but it's basically this. But all of these images are not contained within the drawable directory. They are in fact being pulled from the internet. There's actually a website that's then pulling all of these, or rather, there's actually a website where this application is pulling each of these JPEGs, resizing them on the fly, and then displaying them on the device. And so to give you an idea of what this will look like, I actually have to cause it to shut down. So manage applications running. Whoops, it was right there. Nope. Threads 03, force stop, come back up here, and then go back to threads 03. Now you can see right here as it loads each individual image from the internet and resizes it dynamically. Now, this is a little bit of a white lie, because I did actually, I noticed that it downloaded sufficiently fast that it wasn't really compelling. So in addition to that, I did also add a thread sleep just for a little while, just to make it appear a little bit more dramatic as it did all of this stuff in the background. But how then are we able to do this? Did I see a question?
Can we do that force remove thing from the emulator?
Can we do, yes, you can, yeah, you can actually uninstall from the emulator. Just if you are on the home screen, you hit the menu. So if you are on the home screen, you hit menu and then go to settings, and then there's an applications selection, and then from there you can either manage applications. So you can either uninstall applications from here, you can actually force them to be stopped. There's a variety of options that you have from this menu specifically. So how then are we actually accomplishing this task? So realize that we have a couple of things going on. In fact, this is a relatively complicated application. It does a variety of things, and it even supports passing data on orientation change. And we'll see what that looks like in just a moment. But if I actually take a look at the image adapter for this, realize that now no longer are we using this Java reflection to be able to find what images are available. I did a little bit of a cheat, and because it was already complex enough, just listed the URLs for each of the JPEG files in an array. So I know very, very easily what each of the files are that I want to download. Now, a good next step for this application might be to actually point instead to an XML file that's maybe an RSS feed of images that it would then dynamically download. But that's sort of an additional step. This is a good first step for a sort of a complicated background thread. So what happens here is on our constructor, we basically need to generate a list of URLs. And so we have then an array of type image. And if we look at the image class, realize that it's relatively simple. All it is just a string representing the URL and also a bitmap representing the thumb. So you might recall from Intense 08 that we had an array of bitmaps that stored cache. So whenever we resized one of the images, we stored that into a bitmap array that acted as a cache for that particular bitmap. This case, we're just adding some additional data, in this case the URL, so that we then know what thumb is associated with what URL. And this will be useful for us when we're working in the background thread. So we create an array of image, of this image type, and we're just copying all of the URLs from our array of strings into that. Then we execute our background task. In this case, it's called thumbnail gen, but this again extends the async task, and we can see what this looks like down below. So the async task, I gotta find it, loads thumb task looks like this. So we have, again, we're implementing the doInBackground method, which is the method that will be called by the background thread to actually perform the actions that we want. Notice that if we actually did not do this in the background and we waited for all of this stuff to be downloaded, nothing would be displayed until everything was ready. So that would actually cause quite a large blocking in our UI. This would not be a good thing for us to do. So downloading images in the background is certainly a good thing for us. Another thing, another method that we've implemented in this class is onProgressUpdate. And we haven't seen this method quite yet, but this method can be called by the background method, by the doInBackground method, whenever we have some unit that has been completed. So this is very good for whenever we've downloaded a new image. We can actually run this onProgressUpdate method. This method is then called on the UI thread, and we can do whatever is appropriate to actually notify, say, the adapter that we now have a new thumb and we're ready to display that thumb in the grid view. So basically what has to happen is that, and it's very difficult to see because of the contrast, but if you were to download and run this application on your own device or on your own emulator, you'll notice that each view has sort of a background image that just exists in the meantime while we're waiting for this to download. And so when we create the view for each of these objects in the adapter, which is up here in Get View, then what we're doing, if we don't actually have a thumbnail quite yet, for this specific URL, then what we're doing is we're just setting the image to be a default blank image in the meantime. And only when we have a thumbnail, then we will be able to insert that thumbnail, that downloaded and processed thumbnail, as the image bitmap for that image view. And this again is in the setView method of the image adapter. If you have questions about that, look again at the Intents08, because we had implemented this specific method within that project as well. So what is happening is that in the background, we have passed into this class an array of type image. So notice that here what we passed into it, when I ran that execute, I passed in that images variable. That images variable was again that array of type image, and I had to specify again up here via generics what type of data this doInBackground was going to accept. In this case, it's going to be an array of type image, and that is what we see here as the parameter. So now I've passed this data to the background thread. And this data is now consisting of just an array of these objects, one of which is the URL, and one of which is a bitmap, which for right now is going to be null. And what I want to do is download each of these URLs. So you'll notice that we iterate over each of the objects within this array using this for loop construct up here for image I in the cache. Then we do some stuff that we'll talk about in just a little bit, but the important bit is right here, load thumb, where I want to set the thumbnail field of the image I equal to the thumb that I'm loading. And recall that this method, all of this stuff, is happening in the background, and so even though I have this method, load thumb, that I've defined elsewhere in the class, it's not being run in the same thread. It is in fact being run in the background thread. Yes, did I see a question?
I was just wondering why, I understand like the concept of this image adapter that you're creating a grid view of images, but I was wondering why you have to set bitmap factory settings, like you have to resize the image, as opposed to when you're loading the actual image, it's just being placed in an XML view and you'll have to resize it.
Right, so the question is, why am I doing this stuff? Why am I using in sample size ahead of time? And the reason for that is that these images are sufficiently large and there is enough of them that if I were to just download these images and not resize them and just display them in the image view, I would run out of memory in the application. In fact, as soon as I scroll down just a little bit the application would crash. And the reason for that is that there's just not enough memory in the device to be able to hold all of the full-size images in the views. And even though it would dynamically resize the images to fit the view, and so they would look tiny, in memory they're actually quite large. So the whole point of me doing this in sample size in the case of this application is so that it subsamples. And what that means is that as it's loading the image, it's actually skipping some bytes. You can think of it as sort of skipping bytes. And so when it's loading the image, it's already loading it in a much smaller image size than what it was originally. And so this then loads the image into a much smaller memory footprint. And so I can fit many, many more images into memory and display them much more easily. Now, the second thing to address this question is that I'm also using a cache. So rather than dynamically downloading this and inserting it into the view on the getView method, that tends to be very, very slow. Resizing an image does take a couple of milliseconds, depending on the speed of the device. And so doing that for all of these images can actually take a little bit of time. And so again, this would block the UI. So the reason that we are doing this is that we can download this information, make it smaller in memory so that it then fits in memory, and also cache the thumbnail into an array just so that it becomes very easy. It becomes very easy for us to fetch the already sized image and insert it into the image view rather than having to deal with sort of live dynamic resizing or anything like that that can actually cause slowdowns in the UI.
But theoretically, if you had like enough memory and you didn't re-sample size it, they would fit into the grid view.
Oh yeah, if you had megabytes of memory available to you, then you wouldn't. I mean, then you could be sloppy and not resize it to be appropriate, and it would actually live resize it down to fit the image view. And the way that we know that to be true is with this set scale type. We're actually setting the image to fit in the center of this. And the reason that we're using this rather than relying on proper resizing technique is that in sample size is approximate. It only gets us down to approximately the size that we want as opposed to the actual perfect size that will fit within this view. And so there is a little bit of a resize that has to happen. In sample size only gets it to approximately the right size, and then we have to get the rest of the way by relying on the image views scaling in this case. Yes?
In sample size, what is the dimension of that factor? How much quality will we lose if we specify 4 rather than say 2?
So in sample size, how do we know what factor to use? So basically, in sample size works best in powers of 2. And so it will work best for 1, 2, well, 1 will have no effect because then it's basically reading the same amount of data, 2, 4, 8, so on and so forth. But what you can do when you want to use this, and again, this is going to be approximate, so you would have to do some additional resizing after you in-sample size it to the closest available one, is you first want to find out how many times smaller it is. So for example, if I want to fit a 400 by 400 image into a 100 by 100 space, then that means that it is going to be downsized approximately by a power of 4. And so that's a good fit then for in-sample size equals 4. So if I wanted to do something instead, like I wanted to fit, say, something that is 150 pixels by 150 pixels into a 100 pixel by 100 pixel space, then I may not want to use in-sample size because using an in-sample size of 2 would then make it 75 by 75, which would then be too small for our thing. So basically, you just find the power that you are dividing, that you are scaling it down, and you're finding out how many powers of 2 fit within that. The maximum powers of 2 that fit within that. There is, obviously, if you want to do this properly, a little bit of math that's involved. In the case here, I sort of know that all of the images are a certain size, and in sample size 4 was sort of the ideal thing to fit all of these images. There's no fancy math that's going on here that actually determines individually for each image what would be the appropriate in sample size range to use. So again, there's some complexity to using this, and I'm doing some hand waving towards it, but again, this is something that is sort of tangential to what we're looking at. So I would recommend looking at it online to find out more information on in sample size. So in the background then is there this method that's called load thumb, and we pass into it the URL of the thumb that we actually want to generate. And from that, do we then run some code? So we actually parse the URL as an actual URL. We open a connection, we create a stream, then we decode using Bitmap Factory. We decode the stream, passing into it some of the options that we've set, including the in-sample size, and we create, in essence, just a bitmap that we can then return back to the method that had called this. So if there happened to be a problem, like say there was an I/O exception or the URL happens to be malformed, and by the way, I'm going to give you a big hint right now. If you are doing anything with the internet in your application, you must make sure to include the internet permission in your Android manifest. If you don't do this, it will fail silently, and you will get I/O exceptions all over the place, and you will tear your hair out trying to figure out why on earth you know that this URL exists, but it keeps giving you these problems. So make sure that you update your manifest if you require special permissions. There's more than just internet. There's things like phone and a variety of other permissions as well. Contact list, I think there's a whole bunch that you want to look into when you actually need permissions there. And so that can actually cause some frustration on your part. But coming back to the image adapter, realize that all of this happens in the background because we are running this method from the doInBackground method. So within this, we have some other administrative tasks, like we first want to see if the thumbnail is not null. If it's not null, then we've already generated it, so we're just going to skip it. If is canceled, so is canceled is actually a method that's supplied by async task, and that method returns true if for some reason we want to cancel the background thread. And the reason we might want to cancel it is if the activity is being destroyed, for example, and we actually don't want that to continue downloading images in the background, then we can actually send the cancel signal to the async task and tell it to cancel, and we actually want it to shut down at a reasonable time. But once we have loaded this thumb and inserted it into our image class, then we can publish the progress. We're just saying that we have some unit that has been completed in the background. We actually want to notify the user that that's the case. And again, onPublishedProgress update is the method that's going to be called, and it's going to be called in the UI thread. So what this means is that I can call methods in the UI thread and notify the UI that something is done. So in this case, it runs the cache updated method, which by itself isn't very fancy, but all it does is it tells the image, or it tells the adapter that the data has changed, and it's just going to refresh. And it's just going to refresh all of the views and find whichever ones have been cached and insert it. So basically, every time an image has been downloaded in the background, we're going to run that onProgressUpdate method. That onProgressUpdate method will call this, and this notified data set changed will then refresh all of the views, which will then call that getView method, and we will then be able to show the cached bitmap in the getView method. And so there's some additional complexity here that you might want to take a look at. One of the things that we use in this application is this, let's see, in code3.java. If something has been changed, so if the configuration has been changed, as might be the case with an orientation change, for example, then we can actually pass data from one orientation to the next. And again, don't worry about this for NPuzzle. If you do it properly, you won't have to worry about, well, I mean, it's not even explicitly specified in the specifications what you should do in the case of orientation change. But what happens in this case is that if I'm loading images in the background, what will happen is that if I try to change the orientation of this device, what is going to happen is this. So notice it's downloading images, and when I change the orientation, it restarts. And the reason for that is because everything was destroyed, and then everything is recreated. Now, what I want to do is use this onConfiguration state change to be able to specify, okay, what I want to do is actually persist some data between configuration changes. And you can do that with this method onRetainNonConfiguration instance, and just pass some data from one instance to the next of your activity. In this case, I just commented this out. And what this allows us to do is just make it very easy to support the ability to retain this data. So notice that we're downloading some images here, and when I change orientation, that data is maintained. And again, it's not something you have to worry about for NPuzzle, but that is useful in the case of this when we're doing some slow stuff in the background, some slow tasks in the background, and we actually want to make sure that that data persists between configuration changes. So this is just the nicety that's added to this asynchronous task, or rather to the activity, just that we can support this asynchronous task from having to do multiple bits of data all at once. Yes, a question?
When you're changing when the state is changing and you're saving a persistent, you don't know what image has downloaded. You're just persisting everything.
So what's being persisted, if you look at the source code, what's being persisted is basically that array of image types, and we can then know if a bitmap is equal to null, then that has not been downloaded yet. But if it's not equal to null, then it has been downloaded, and we can just skip that. And that's why in the background task, do we ask the question? Let's see. We ask the question. Where is it? Down here somewhere. If i.thumb is not equal to null, that means that we do not have to update it, and so we just skip this particular image because it's already been doing it. But it does just send that same data to the newly created version of this activity, and it will continue running this asynchronous task in the background. So again, this is a more complicated way. This is something that you should take a look at if you need to use asynchronicity in your own application because you have some very complicated algorithms that are running in the background, and you need to be able to support background threading and some other fun stuff. But with that, I want to thank you all very much for your attention these past few weeks. Enjoy your spring break. We will see you in 2 weeks when we start talking about iOS. So thank you all, and we will see you then. Thank you.